So what we're going to do is a couple more examples based on what we did yesterday, just so you can see some more of this at work, see those tables used again. And so we're going to pick up where we left off on the notes yesterday, and we're going to start with the bottom example. So the bench press results of a population of 21,000 athletes are normally distributed. That's good news. We can use our bell curve. The mean number of reps of a given weight was 22. And the standard deviation is 5. Okay, so we can sort of visualize our bell curve now. You don't have to make it be a formal bell curve with all the numbers drawn in, but we know that this is going to be 22. And then I'm going to have all of these markers that are just going to be 27, 32, 37, and so on, and same in this direction. So just so you're picturing what's going on with this bell curve right now. What percent of athletes did less than Greg, but more than the average if Greg did 31 reps? So one thing we're noticing here is that Greg falls right about there, and our empirical rule is not going to be very helpful to us. So we want to know what percentage of the athletes did worse than Greg, but better than the average, because Greg is there at 31. So a couple things we need to do first is we need to get Greg's z-score. We need to figure out exactly where Greg is on that x-axis in terms of normal distributions. And then we need to figure out the percentage of athletes that did worse than Greg. Okay, so we need a z-score. So remember that the z-score is determined by taking the number, subtracting the mean, and then dividing by the standard deviation. So in this case, it's 31 reps minus an average of 22 reps divided by a standard deviation of 5. So this works out to a z-score of 1.80, and we can use that now when we go to our table to figure out exactly what percent of the athletes would have done less than Greg, because we're going to focus on that first. Less than Greg, but more than the average. All right, so let's take a look at our z-table. And this is the table that represents numbers that are above the mean. And the only reason I don't need the numbers below the mean is because Greg's score was above the mean. So I don't need to worry about the table that talks about negative z-scores. But Greg's z-score was 1.80. So that's the amount of students. If this is Greg right here, then that means that there is 96.41% of the athletes that did worse than Greg. But remember, we're not just asking what percent of athletes did less reps than Greg. We're asking what percent of athletes did less reps than Greg, but did more than the average. And we know that the amount of athletes that do less than the average is 50%. So what I'm trying to find here is what percent of athletes are in this range. So just like yesterday, the way that I'm going to do this is I'm going to take Greg's number. Greg's number is 0.9641, and I'm going to subtract 0.5000, and that's going to leave me with the amount of data that's in the difference between those ranges. So that leaves us with 0.4641. In other words, about 46.41% of the data. So that answers that first question. And now the second question, which we're not going to do right here just in the interest of time, but the second question asks how many athletes did better than Greg. So we'll need to find that information there, and we'll need to turn that into a number of athletes. So you'll need to figure out how much data is in this range, and then multiply that as a decimal by the total number of athletes who participated in this challenge. What I want to do now, though, is one example of a delta math problem like what you're going to see in the homework today. So here's an example of one that you might get today. For males in a certain town, the systolic blood pressure is normally distributed. That's great news. We can use a bell curve with a mean of 110 and a standard deviation of 5. So already I'm going to sort of visualize my bell curve. I'm putting 110 here, and then I'm going up 115, 120, 125, and now I've got a pretty good picture of what this looks like. Remember that this is the mean, and then this is the mean plus 1 standard deviation. This is the mean minus 1 standard deviation, okay? What percentage of males in the town have a systolic blood pressure that's between 102 and 119? So 102 would be somewhere around here, and 119 would be right about there. So what we're trying to figure out is what is the percentage of data that's within this range. And I know that it's going to have a bell shape to it, so it's going to look something like that. So what I'm going to want to do is find the z-score for 102, find the z-score for 119 first. Okay, so my z-scores for 102 is going to be 102 minus the mean divided by 5. And then my z-score for 119 is going to be 119 minus 110 divided by 5. So we end up with a z-score here of negative 1.60 and a z-score here of 1.80. So we're going to go to our tables now, and we're going to look at how much data lies to the left of each of those numbers. So here's where we're going to find our negative 1.60. That's right there. And so what that tells us is that there is 0.0548 of our data to the left of negative 1.6 standard deviations away from the mean. So we're going to keep that number in mind, 0.0548. So now let's go over to the right side. And we got to find our 1.8, which we just used. And that's going to be this data here, and that is 0.9641. And so if I'm being asked what percent of my data is between those, all I have to do is take this amount of data and subtract this amount of data, which I guess I can represent here in red. And that's going to give me this section here in the middle that I'm looking for. So I just have to take those numbers and subtract them. And Delta Math is asking for this value to the nearest thousandth, so I'm going to give 3 decimal places. So if I do 0.9641 minus 0.0548, that gives me 0.9093, and to the nearest thousandth place I would say that that's 0.909. Now there is a statistics calculator that Delta Math will let you use, and if you figure out how to use it, that makes this process go very quickly. I think it's beneficial for you to learn from using the tables, so I'd encourage you to use these tables, which you have access to. I sent them to you yesterday in the question through Google Classroom. But if you do want to use that calculator, which is like one of the ones that you would have had on the TI-84, you can use that as well.